Hey data heroes, is your data pipeline a mess? Are you still manually clicking buttons to trigger giant ETL jobs? Are you tired of building separate schedulers for every single system in your architecture? If you are building a modern data infrastructure, you need an orchestrator. And today we are diving into the best orchestrators in the data world, Apache Airflow versus Databricks Workflow Jobs. We are going to break down who is the control freak and who is the all-in-one solution. And I will show you exactly when to pick the open source hero and when to pick the all managed solution. Make sure you hit the subscribe button because right now we are jumping into the original kitchen manager, Apache Airflow. Apache Airflow is the autonomous chef of your data kitchen. It doesn't cook the food, it just makes sure that the ingredients are prepared, the oven is on, and the sequence is perfect. Let's see how it works with Python DAX. Apache Airflow is the autonomous chef of your kitchen. But why? Because Airflow is not designed to cook the big data meal itself. Apache Airflow's expertise is orchestration, making sure every step in the complex recipe is perfectly sequenced. Apache Airflow has two core concepts. The first one is the DAG, Directed Acyclic Graph. The DAG is the entire recipe. It is your complete workflow. It defines which steps will run, when, and in what order, and all is written in Python language. A task is a single step in the entire recipe, such as fetch user data, extract and transform user, load and display result. Every task is a single independent unit of work. Okay, now we understand the concepts. But how Apache Airflow chains the tasks together and share the ingredients? The magic lies in two places, bitwise operator and XCom, cross communication. The bitwise operator explicitly controls the order. In this example, step 2 will only start once the step 1 is completed, and step 3 will start once the step 2 is completed. It is clean, readable, and it is the core of Apache Airflow's scheduling logic. And what is XCom? XCom helps us to share the ingredients. For example, the fetch user data step will create a JSON file, and step 2 will automatically grab that JSON file with the XCom usage. So with XCom, you don't need complex database lookups. Apache Airflow handles the flow of the data effortlessly. Now let's prove it. We need to run this on an Airflow environment. First, let's briefly look at how you can run Airflow in your local, and then we will jump into the code. Setting up Apache Airflow is a little tricky because it requires a complex infrastructure and it requires components such as scheduler and a database and a web server. But in our local, we can use a Docker Compose YAML file to set up all the required components. So from this page, you can download the Docker Compose YAML file to your local and just run and spin up all the required containers. Since I already set up Docker Compose YAML file, I will just spin up all the required Apache Airflow containers. While the Apache Airflow containers are spinning up, let's check our code. We will create a Python file for our workflow, and for Apache Airflow to recognize it, we will have to put it into the DAX folder. Let's quickly review the logic. First, we are defining our DAG. After configuring the DAG, we will just create 3 separate tasks. The first one is fetch user data. We will use this fetch user data task to get some sample random users from the random user API. In the extract and transform user task, we will do some simple cleaning. And in the last task, load and display results, we will just print the results to the screen. And we are setting the dependencies by using the bitwise operator as shown below. Okay, now let's jump into the Apache Airflow graphical user interface. You can reach it from your localhost 8080. From the main page, you can click the DAX section to see all of your workflows. The first one is the workflow I just created, so I am going inside of that workflow. First, let's head to the graphical view. You can reach it from the show graph button here. From the graphical view, you can see the relationships between your tasks very easily. So step 1, step 2 and step 3 are chained all together. Now let's trigger our workflow. I will hit the trigger button and start my workflow. You can check the status of your workflow from the run section. Currently, it is not started yet. Now our workflow is running. Great, my workflow is completed. Now let's check the results. From the last triggered run, I will just select my step 3 task, which is the load and display results. And here in the log section, you can see the results. It is successful. So Apache Airflow, our autonomous chef, managed the workflow and sequence perfectly. But remember, this was only for one single user. But what will happen if the API returns 100 million records? Of course, Apache Airflow's infrastructure will not be able to handle it. Now let's check Databricks and understand how it handles massive data processing workflows. Databricks is an all-in-one platform. It integrates orchestration and execution into the Lakehouse platform. In the Apache Airflow, you need to manage the complex infrastructure and the components such as scheduler, web server, and Postgre database. But Databricks is a fully managed environment and handles the infrastructure for you. Let's prove it with our demo. I log in into the Databricks free edition. I just created one single notebook. Inside the notebook, I used Python language to fetch the data, to transform the data, and load the results. In Databricks, we don't need an Airflow DAG file. We will first go to the jobs and pipelines, then create a job. I renamed this job as Databricks Demo Job, and I created a single task with the name Databricks Demo Task, and I'm selecting the notebook that I've shown to you before. That's it, let's create the task. So, our workflow job is ready. When I hit the Run Now button, this is the key difference. Databricks will automatically provision a serverless job compute which Spark is running inside it. This cluster will handle the massive scaling and it will terminate itself once the workflow job is completed. Let's start our job. So our job is started. So our workflow job is completed and it printed out the results successfully. Great! Databricks Workflow Jobs is excellent for jobs inside the Lakehouse platform. But if your workflow jobs needs to touch some external different systems, such as some legacy databases, Databricks could have some limitations. So we have the versatile, open source, control freak Apache Airflow versus execution integrated Databricks. Which one is right for your project? Let's jump into the final comparison. Let's put Apache Airflow and Databricks Lakeflow jobs side by side to compare them. Let's start with scope. Apache Airflow is a universal orchestrator. It manages workflows that jumps between public cloud such as AWS, Azure, Google Cloud, and also on-prem. Databricks Workflows is, on the other hand, Lakehouse central. Second comparison, execution. This is the biggest difference. Airflow only manages orchestration, and Apache Airflow requires external compute resources to execute the jobs. Databricks is, on the other hand, provides compute power with its Spark job clusters and handling scaling automatically. Third part, management. Apache Airflow is a self-managed environment. You need to manage the components such as scheduler, web server, and database separately, and it comes with a high overhead. Databricks Lakeflow Jobs is, on the other hand, a fully managed serverless environment. It means less time in infrastructure, more time on data. Last point, the cost. Apache Airflow is an open source tool, which means the software is free, but you need to pay for the underlying infrastructure. Databricks comes with its own DBU, Databricks Unit Model Costing Model. You can use automated job clusters, which terminates itself after workflow jobs are completed. So who wins? Actually, neither of them. The winner is the tool that solves your specific architecture problem. Choose Apache Airflow if you have complex, multi-cloud, multi-system environments that requires centralized orchestration. Choose Databricks Workflows if your data processing occurs in a Spark environment within a Lakehouse platform. And the best part, they can work together. Airflow could be your primary scheduler and it can orchestrate Databricks Lakeflow jobs. Which one are you using? Let me know in the comments below. If you found this comparison useful, please hit the like button and subscribe for more deep diving into data engineering. Thanks for watching and I will see you in the next one.